So, friends, till now what we did up to the last session was we have started with the, IoT access technologies, right? And when you talk about the IoT access technologies, I said that there are many options that we have, right? One of the option was like NFC, right? But we have not covered up in that session. I will help you out with that also. Then we have looked at this diagram, like you have a short range communication option, medium range, and the long range communication options, right? And again, according to the frequency allocations, we can divide these access technologies into the either licensed spectrum or the unlicensed spectrum. And then we have started discussing the Bluetooth, and I said clearly you the history of the Bluetooth, and this is the number of devices that we need to have by 2018, and we are already in 2021, and we discussed the Bluetooth in the bit detail, how it does the communication, right? And what are the different versions that we have, and especially we try to compare actually the Bluetooth with the Bluetooth low energy. And when I say low energy, our objective is that we want a device to be operated with very low power, right? So we want to enhance the device life extensively, and the latest version of the Bluetooth is the Bluetooth 5. Again, its objective is to increase the bit of data rate, right? And in the context of the BLE and IoT, we also discussed how BLE could be useful in contributing the IoT domain, right? And then about the BLE, we discussed that how you can avoid the interference with the 802.11, because Bluetooth also operates around 2.4 gigahertz, and Wi-Fi also operates around that. So how you can do so, there are some known overlapping channels, and that we are avoiding, and we have counted. Still, if you avoid all these things, you are getting many channels which can be utilized, like including the control and the data channel. So that's what we have discussed, friends, right? And we did a great comparison between the classical Bluetooth and the Bluetooth low energy and Bluetooth 5, and I have clearly explained you the kind of latency that has been obtained with the Bluetooth low energy, right? And the power consumption, very important here. Like you can see in the Bluetooth classic, we want to have a 1 watt of power, where it's in the range of 0.01 to 0.5 watt, right? So that's a very less power consumptions that we are getting with the BLE. And we discussed this scatter net and everything, and then we started with another unlicensed spectrum and low power wireless communication mechanism, and that is called IEEE 802.15.4. So basically, I already said, based on the 802.15.4, actually believe me, this 802.15.4 will give you two layers basically. If I talk in the context of the TCP/IP model, it gives you the physical layer and the data link layer. But to be more specific, even data link layer has been divided into two parts. You must be knowing, right? Medium access control layer and the logical link control layer. So basically, when we are talking about 802.15.4, actually it gives you the physical layer and the MAC layer. Now on top of that, there are a lot of standards available, and one of the standard is, let's say, Zigbee, right? So first I will be briefing you about 802.15.4, and then slowly and gradually we are moving to the Zigbee. So IEEE 802.15.4 is a standard defining a physical and medium access control layer. I already said MAC is a part of your data link layer. Your data link layer has two components, LLC and MAC. So basically 802.15.4 defines physical and the MAC layer for low data rates wireless communication. Very important. It's not designed to transfer the large file over the internet, right? If you want to transfer, let's say, the device status, for example, you want to transfer the information like whether the door is open or closed. This is very useful technology. That's what we are trying to say. The standard is the foundation for a wide range of open and proprietary solution of short range. It's a short range wireless communication, operates in unlicensed spectrum. So it enables you to create a wireless personal area networks. And even in some cases, it can go up to the medium range. So this is the alliance, like WISUN Alliance is an industry association founded in 2012 with the goal of driving adoption of an IEEE-802.15.4 based smart utility networking standard. This is very important for interoperability bearing its name. I will explain you how it has bring the interoperability. What we mean by that is, see, there are a lot of vendors in the IoT spectrum. So each vendor is coming up with a specific device, right? And each device may have a different protocol. Then how these devices will communicate internally? So that's a big challenge, and that's how 802.15.4 has helped. So this we already know. Wi-Fi is developed by Wi-Fi Alliance, and that's 802.11, right? And WiMAX is again 802.16, and Wi-SUN, that's what we are talking about, is 802.15.4. So the Wi-SUN Alliance performs the same function as the Wi-Fi and WiMAX forum. Each of this organization has an associated standard body as well as a commercial name. Right, so this is just to show you where this Wi-SUN and 802.15.4 stands in comparison to Wi-Fi and the WiMAX. Right, so let's talk about the security. For example, if you have remembered, I said that in the BLE, right, we are also using the security in order to transfer the data. So because, you know, when it comes to the, let's say, home automation, for example, so maybe let's say you are transferring the status of your house over the network. So security is going to be a big concern, right? Privacy is going to be a big concern. So what is there in the 802.15.4? Its specification uses advanced encryption standard, that is AES, with a 128-bit key length as the base encryption algorithm for securing its data. You understood very well what is an encryption and decryption and what is an AES, right? So I'm not moving into that, but this is just for your updates, right? Now, what are the technology characteristics? The 802.15.4 physical layer supports deployments in the 868.915 megahertz or 2.4 gigahertz ISM band. ISM stands for industrial, scientific and medical bands, right? So at the data rate of varying from 20 to 250 kbps. This is very important, you should understand. Right now, in different countries, Zigbee operates at different frequencies because it operates in the unlicensed spectrum. So again, you have a third competitor over here. See, if I talk about 2.4 gigahertz, we already said that Bluetooth also operates at 2.4 gigahertz. Wi-Fi also operates in two different domains, 2.4 and 5 gigahertz. But let's say if I fix to 2.4, then again we have a third variant, which is Zigbee, that also try to operate at 2.4 gigahertz, right? And you can see the data rate. It is in terms of kbps. So I already said the objective of 802.15.4 is not to allow you to transfer the file on the internet. It is for machine-to-machine communication. It is contributing in the IoT spectrum, right? In addition to being a low cost and offering a reasonable battery life, very important, this access technology enables easy installations using a compact protocol stack while remaining both simple and flexible. What are the applications? You can think of home and building automation, automotive networks, industrial wireless sensor networks, interactive toys and remote controls, right, where we can use this 802.15.4. So what are the standardization and alliances? Right now, while there is no alliance or promotion body for now, see, this is very important, there is no promotion body for 802.15.4 per se. The IEEE 15.4 physical and MAC layers are the foundation for several networking protocol stack. Right, so now on top of this 802.15.4, lot of technologies comes up. We gonna discuss those. This protocol stack make use of 802.15.4 at the physical and link levels, but the upper layers are different. Now, for example, when we talk about Zigbee, Zigbee is using, let's say, IEEE 802.15.4, and above the MAC layer, it has a different protocol stack. Right. Similarly, another example could be a thread. At the lower layer, physical and MAC layer, it's using IEEE 802.15.4, but at upper layer, it has a different mechanism. Similarly, 6LoWPAN, right? It has the same things, right? I hope you are able to see on this slide, right? So 6LoWPAN, again it's lower layer, that means physical and make layer is nothing but IEEE 802.15.4, but at upper layer it has a different set of protocols, set of rules, right? So what we are trying to say, this protocol stack make use of 802.15.4 at the physical and link layer, but the upper layers are different. These protocol stacks are promoted separately through various organizations and often commercialized, right? So one of that is the Zigbee. So let us start with the Zigbee now, IEEE 802.15.4. So basically Zigbee uses 802.15.4 at physical and MAC layer, that you can see very clearly from this diagram, right? I hope you are able to see this diagram, and here you can see IEEE 802.15.4 is used for physical and MAC layer. Then above that, what you have is a Zigbee platform stack, where you have a network and security layer and application support. And then, as I said, Zigbee will be playing a big role to have an interoperability. Now how that magic is done, so here what you have is Zigbee or a vendor specific application profiles. So for example, let's say you bring two devices, right? You bring two devices like this, let's say two devices, and both the devices has a Zigbee. Now if these two devices support a same profile, even though they are from a different vendor, but if they have a same profile, I will tell you what I mean by profile. Let's say the profile is home automation, for example. Then these two devices, even though they have been manufactured by two different vendors, still they are able to communicate. So that is how it is providing an interoperability, and that magic is done by having a Zigbee or a vendor specific profile. So if they are supporting that profile, that means they have a communication capability, right? So Zigbee is the most high profile technology based on 802.15.4 in the WPAN space. It launched in 2003 and promoted through Zigbee Alliance and aimed at smart objects and sensors that have low bandwidth, very important, low bandwidth and low power needs, right? So this is the Zigbee protocol stack that you should understand. The lower layer I already said, there is a Zigbee platform stack, and above that you have a Zigbee or a vendor specific profile, right? So what are the characteristics of the Zigbee? So actually Zigbee operates in 2.4 gigahertz ISM band. I already said industrial, scientific, medical band, and this is unlicensed. That means and you don't require to pay any fees to use this frequency, and you can use it without anybody's permission, right? It is 915 megahertz in America and 868 megahertz in Europe, and even in India it operates around this only, 868. Ultra low power consumption and mesh network support. This is very important. Please understand, your Bluetooth supports peer-to-peer networking, right? Bluetooth supports peer-to-peer networking, but latest update in the Bluetooth is also that they come up with a Bluetooth Mesh 1.0, which will try to support the mesh topology. Now you may have a question, okay, when you are talking about a mesh topology or peer-to-peer or star, let's focus on these three. So when I say star, you understand, right? We have a central device, and every device can communicate via that central device. When I say peer-to-peer, the device-to-device communication will happen, right? The way we are doing in Bluetooth. So Bluetooth may support peer-to-peer as well as star also, right? If you look at Zigbee, it supports the mesh network. What I mean by mesh topology, each device can communicate with every other device of the network, and that's what you mean by the mesh network support, right? So the maximum data rate that is possible is 250 kbps, please understand, and its range up to 100 meters depending on the transmit power level and the indoor conditions, what kind of obstacles you have in between. It needs a large addressing space and can support a maximum of 64K IoT devices. If you remembered, in a single Bluetooth network we could have maximum 8 devices, out of that one has to be master, right? That's what we have said. And now when you are using Zigbee, the maximum devices that you can have is 64K, right? So this is the scalability that it gives you. So larger network can be supported by linking multiple Zigbee networks. So if your objective is to even support more than this, what you can do is you can have a interlinking of a Zigbee networks, and each supporting maximum 64K devices, right? So these are the basic characteristic of the Zigbee. This is very important. It's a self-forming. Zigbee network can configure itself automatically, so no human intervention or no control mechanism is required. It has a self-healing mechanism. Zigbee can reconfigure itself dynamically in situation that Zigbee node becomes faulty. So they have a fault tolerance capacity or correction capability. It provides interoperability. I already said different Zigbee modules from many different manufacturers in home automation and industrial device can operate together, provided they have a according to that stack, they should have a same profile. They must be supporting that profile, right? So these are the self-forming, self-healing, and interoperability. What are the applications? Smart home and smart building use cases with applications tailored to lighting, home automation, and security have widely used Zigbee as their IoT connectivity solution. Even though Zigbee modules do not exist in most of the existing smartphones, our smartphone does not have a Zigbee, right? Tablets or computers, Zigbee is used as the only technology in home products such as Samsung Smart Things. You can do a Google search, Samsung Smart Things and Philips Hue, right? This is the light available in the market. Street lighting is an excellent example that can be controlled using Zigbee mesh topology, since it's capable of providing functionalities such as remote management for a large network of devices. This is very important, right? So these are the products already available in the market which are based on this standard, right? The advertisement of this you must be watching on the television, right? Very innovative ad. Now I said already, if you look at this slide, I already said 802.15.4 will give you what? तो आपका 802.15.4 कॉमन रहेगा. आप अगर आप 6LoWPAN की बात कर रहे हो, या आप थ्रेड की बात कर रहे हो, आप Zigbee की बात कर रहे हो, your physical and make layer will be fill in the blanks for everyone, those who are in the class. Your physical and make layer for Zigbee, 6LoWPAN and thread will be physical and make layer will be same for Zigbee, 6LoWPAN एंड थ्रेड. ये तीनों के लिए आपका फिजिकल एंड मेक लेयर सेम रहेगा. आई एम ट्राइंग टू से दैट your 802.15.4 will be common for a Zigbee or a thread or a 6LoWPAN, right? And here we talk about the Zigbee. Zigbee की कुछ कैरेक्टरिस्टिक मैंने आपको बता दी. डेटा रेट इज स्मॉल, रेंज इज लो. आई ऑलरेडी सेड एन एप्लीकेशन जो प्रोडक्ट अवेलेबल है मार्केट में, उसका भी मैंने आपको एग्जांपल दे दिया इधर Zigbee का, और उसकी सारी कैरेक्टरिस्टिक बता दी, कितने डिवाइसेस वो सपोर्ट करता है इन अ सिंगल नेटवर्क कंपेयर टू ब्लूटूथ. आई ऑलरेडी एक्सप्लेन टू यू, right? Let's move to another technology which is very interesting. 6LoWPAN. Right now this 6LoWPAN is actually based on the आपका फिजिकल और डेटा लिंक तो सेम रहा, वो फिजिकल एंड मेक लेयर, तो वो क्या हुआ 802.15.4. उसके ऊपर इसने क्या किया, इट सपोर्ट IPv6 ओवर लो पावर वायरलेस पर्सनल एरिया नेटवर्क. वेरी इंपॉर्टेंट. व्हाई? आई विल टेल यू. Right? It's a networking technology or adaptation layer that allows IPv6 packets to be carried efficiently within the small link layer frames, such as those defined by IEEE 802.15.4. I will explain you. Now, please understand, when you are using a Zigbee kind of devices, right? For example, let's say we have a one device over here. Let's say a bulb from Philips, like here, right? Now, if it has a Zigbee, it has to be connected with some gateway. For example, my Raspberry Pi board or my Arduino board could work as a gateway, and then those gateway get connected to the internet. So this bulb has to be connected to some gateway, and then gateway will connect it to the internet. So that is how this bulb can communicate, which has been supported from which has a Zigbee interface, can communicate with the internet or some cloud platform via gateway. This device does not have a direct capability to get connected over the internet. What you can do here is, if you put let's say IP support, then what you are doing is you are providing a capability to the device to directly talk to the any device on the internet, right? And that is where the 6LoWPAN came into the picture, right? So and 6LoWPAN is using IPv6, not the IPv4, right? It is using IPv6, not IPv4. Now you might be surprised here, because when we are designing a technology for IoT, we have to keep it lightweight, right? And if you look at the header or the addressing size of IPv4 and IPv6, IPv4 is quite compact compared to IPv6, and still we are using IPv6. There are some reason. I wish you to work around that if possible at your end. Otherwise, we will be touching upon that also. So, what are the advantages? It is more suitable for higher density, right? What I mean by higher density, in a smaller area, you can have more devices. No net necessary, so network address translation is not required. I already explained to you, like with that example of the Philips light, right? You don't require the intermediate gateway, right? Possibly of adding innovative techniques such as location aware addressing, right? What are the disadvantages? It's a larger address width. I already said it has a 128 bits of address space, but still there are some optimizations possible. Complying to IPv6 node requirements, right? You need to, in order to get connected with the IPv6 networks, actually that node has to be compliant, right? What are the characteristics of 6LoWPAN? The way we have looked at the characteristic of Zigbee, we are looking at the characteristic of 6LoWPAN. It's a small packet size, 16-bit short or IEEE 64-bit extended media access control address, right? This is how IPv6 has been compressed. It has a low bandwidth, again please remember, right? The way in Zigbee also maximum data rate that you were getting is 250 kbps. Here also the same, but what is additional thing you are getting is the node has a capability to get connected directly into the internet device, or directly it can communicate with the internet device. What is the range? Its range is between 10 meter and 30 meters. Right? Topologies include star and mesh. It support both the topologies. Like Zigbee also support the mesh topology. It's low power, typically battery operated, relatively low cost, right? And inherently unreliable due to the nature of devices in the wireless medium, right? So it's unreliable, right? 6LoWPAN applications, very important. Equipment for health monitoring, right? Environment monitoring, for security, for a home automation, for a building automation. Like what you have seen for a Zigbee, the same things can be applicable to 6LoWPAN, but the advantage, as I said, you don't require intermediate gateway. The device has a capability to directly communicate with any internet connected device. So these are the applications. Another technology, again, let me call back the same slide, right? As I said, my underlying technology is going to be the same. Right, on top of that, I could have a Zigbee, I could have a 6LoWPAN, and on a similar fashion, we could have a thread also. Right, so thread is again a low power, secure, and internet based mesh networking technology for home and commercial IoT products. You look at here on this diagram. Your physical and make is same, what we have for Zigbee or what we have for 6LoWPAN. Right, above that, what you have is where is the change in the thread? So basically, right here there is a change, right? Here there is a change. You can see here the thread standard is a stack built on top of the 15.4 physical and make. The thread stack has built-in feature for IP routing, that is 6LoWPAN, security and commissioning, right? So this is the additional benefits that you have, right? Security and commissioning. And here on top of that, you can have an application. So this is the thread protocol stack that you can have. These are the thread characteristic. The way we have looked at the characteristic of Zigbee and 6LoWPAN. These are the characteristic of the thread. Simple network installation, startup and operation. It's secure, right? Device do not join the network unless authorized, and all communications are encrypted and secure. Again, the data rate is same as what we were getting with earlier two technologies. Right, and it can support up to 250 devices, right? So for example, if my requirement is like to have a 250 devices only, probably this could be a good option. But if my requirement is to have a in 1000, probably I need to go for a Zigbee, Right, the thread domain model allows scalability up to 10,000 of thread devices in single deployment using a combination of different connectivity technologies like thread, Ethernet, Wi-Fi, and so on. So those kind of interconnections also possible. Right, typical devices provides sufficient range to cover a normal home. Low power devices efficiently communicate to deliver an enhanced user experience with years of expected life. Years of, very important, under normal battery conditions. Devices can typically operate for several years on AA type batteries using suitable duty cycles. It's a very cost effective, compatible chipsets and software stack from multiple vendors are priced for mass deployment and designed from the ground up to have extremely low power consumption. Right, so a lot of vendors are there which manufacture this protocol stack on a chip. Right, and this is the network architecture. You can see even thread could be interconnected with the Wi-Fi. So here you can see this is the end device router which are eligible. These are the thread router. This pentagon represents the thread router, right? And there is a concept of the leader here. So this is a leader which may do the aggregation of the data, and you have a thread link. So this orange line represent the thread link, and these are the border routers, and through border routers you can connect with the other technologies. Right, so this is how your thread network architecture. These are the thread application. Now most important thing you should try to understand, it is being an IP based standard. Please understand, ये मैंने strike out किया है. It is an IP based open standard. Please try to understand. Thread allows smart home devices to securely and reliably connect directly to the cloud. You don't require intermediate gateway, as I have explained. Home automation using IoT devices such as lights, thermostats, door locks, and security cameras. Right, I may be showing you one of the demo at my home, maybe in the next session, how we are using this kind of this kind of products available in the market. Right, so this is the market forecast. You can see for 802.15.4 device shipment. Right, starting from 2017 to 2023, and we are here almost. Right, and this is the mobile devices, and you can see, right, the number of devices. Right, and these devices are in the million. Right, so probably we are here almost near to this one. So according to the different application, let's compare Zigbee and Bluetooth, because we have already discussed. Right, so what's the difference? Maybe this could be an important question as far as your Viva or examination is also concerned. So I wish each one of you to focus on this slide. So the first one is the power profile. So Bluetooth में goes for days. For example, आपके पास अगर वो smart fitment belt है, उसमें Bluetooth है, right? So it may go for let's say 8 days, 9 days. Whereas Zigbee, it could be in years. Right, complexity, bit complex. It's very simple in the design. How many nodes you have other than the master? 7. Here you can have a 64K. What is the latency? Latency is the delay actually. Right, so it's in terms of 10 seconds. Please understand, latency is 10 seconds. Here very low latency, millisecond. Right, you understand the difference. Range, it's 10 meter. Or maybe nowadays, if you talk about latest Bluetooth technology, it can go 50-60 meters. But, it really depends on the locations and everything and what kind of obstacles you have. Here it's 70 meter to approximately 300 meter. Right, extensibility, yes, it's possible. Data rate is high. This is the benefit in the Bluetooth. Right, even the Bluetooth 5 supports the data rate up to 2 Mbps. Whereas here the data rate is very low. What we use here is the security 64 and 128 bit. Here we are using the 128 bit AES, and on top of that application layer security also we are using. Right, so that's a difference between the Zigbee and the Bluetooth. Right, and this is a fantastic slide that you should look at the comparison of all these three, and this is what we're gonna discuss in the next topic, that is Wi-Fi. So let me show you this slide. We have looked at the Bluetooth low energy, Bluetooth classic. You can see the number, it's 802.15.1. Here it's 802.15.4, that is your Zigbee, and this is still we have not started, we're gonna discuss it. But you know Wi-Fi is 802.11. Frequency, which frequency operates BLE 2.4 gigahertz, Bluetooth 2.4 gigahertz. This is 0.8, that is, you know, I already said 868 megahertz, some operates in 900 megahertz and also 2.4 gigahertz. And Wi-Fi we have two frequencies, 2.4 gigahertz and the 5 gigahertz. Right? What about bandwidth? Low, it's medium, right? It's very low Zigbee, and Wi-Fi bandwidth is very high. You know, even I am using Wi-Fi right now to deliver this session, right? Power consumption very low because it's a low energy, it's a medium. Zigbee is also power consumption is very low, but Wi-Fi the power consumption is high, and that's the reason I have to have a charger or a battery like a laptop. Even mobile, if you keep your Wi-Fi on, it consumes a lot of battery power. So one of the advice for all of you, if you are not using Wi-Fi, you make it off. It will save your battery, right? What is the battery life? It's a months to years here in the BLE. It's a days in the Bluetooth. Here again Zigbee months to year, and in Wi-Fi it's hours. So laptop battery always specified in hours, right? What is the network size in BLE? It's undefined. Bluetooth Classic 7, 64,000 plus. We already said Wi-Fi 255 machines you can connect in a one network, right? A maximum 255. Range BLE short to medium, Bluetooth Classic very short, Zigbee is medium, and here Wi-Fi is medium to long, right? Because it supports theoretically 250 meters. You can think easy of use, simple to use. All are almost very simple to use, right? Only here Wi-Fi we need some kind of configuration and everything, otherwise it's very simple, right? This is very adaptable, this is also adaptable, right? Adaptability is bit low, but I already said it makes you interoperable, right? If vendors are supporting a profile, it is interoperable, right? And it's high. Primary applications, Bluetooth BLE is wearable, as I said, fit belt, for example, mobile phones. Again, classic also in the mobile phone, mouse, keyboards, official and industrial automation devices. Zigbee, industrial automation, home automation, smart metering. Wi-Fi you already know, right? Laptops and even some light or some home automation devices can also have a Wi-Fi, right? But provided it needs to be operated from a main supply. So this slide will clearly tell you about the differences between the BLE, Bluetooth Classic, Zigbee and Wi-Fi, right? And so obviously the next topic that we're gonna start is actually this one, Wi-Fi, and there are a lot of standard in the Wi-Fi. So in the next session I am going to speak about the Wi-Fi, right?